Hello everyone. In this video, I am explaining how to find summation of exponential series. Let us first define what is an exponential series. So we have the function e power x. The infinite series representation of e power x is given by 1 plus x by 1 factorial plus x square by 2 factorial plus x cube by 3 factorial plus so on up to x power n by n factorial plus so on. So this series is called as exponential series. This is the basic exponential series. This series is obtained using Maclaurin series. If you don't know what is Maclaurin series and how to obtain Maclaurin series, I have already uploaded a video on Maclaurin series. I'm sharing the link in the description box. Please watch that video first. Now, if you replace x by minus x in the above series, then we'll get 1 minus x by 1 factorial plus x square by 2 factorial minus x cube by 3 factorial plus so on up to plus minus 1 power n into x power n by n factorial plus so on. This is the value of e power minus x. Now if you put x equal to 1 in the first series, then you'll get 1 plus 1 by 1 factorial plus 1 by 2 factorial plus 1 by 3 factorial plus so on up to 1 by n factorial plus so on. This value equal to e to the power 1, that is nothing but e. Now we need some useful results to obtain the summation of exponential series. They are, suppose if you have summation 1 by n minus r factorial n equal to 0 to infinity. This summation is same as summation n equal to r to infinity 1 by n minus r factorial. That is because here it starts with 0 to infinity. Even if you put n equal to 0, that gives you negative factorial. Negative factorial is meaningless. Therefore, for all values of n which are less than r, the terms will get eliminated. So you will have from n equal to r. So when n equal to r, you will get 1 by 0 factorial. 0 factorial is nothing but 1 plus then n equal to r plus 1, then you will get 1 by 1 factorial, then r plus 2 minus r, that is 1 by 2 factorial plus so on up to 1 by n factorial plus so on up to infinity. The value of this is equal to, we already know, that is equal to e. So you have to remember this first formula. Summation n equal to 0 to infinity 1 by n minus r factorial is same as summation n equal to r to infinity 1 by n minus r factorial, and its value equal to e. See, for example, summation n equal to 1 to infinity 1 by n minus 1 factorial is directly equal to e. You can write. Similar summation n equal to 2 to infinity 1 by n minus 2 factorial, that value is also equal to 2. Similarly, if you have summation n equal to 0 to infinity 1 by n minus 3 factorial, that is also equal to e, because n equal to 0 to infinity is same as n equal to 3 to infinity summation of 1 by n minus 3 factorial. This value is equal to e. In all the cases, irrespective of r here, value of r here, its value equal to e. Now one more result, summation n equal to 0 to infinity 1 by n plus r factorial. I need the value of this sum. So this is equal to, put n equal to 0. Here you can start directly with n equal to 0 because as their sign is positive. So getting negative factorial here won't appear. Therefore n equal to 0 means 1 by r factorial plus 1 by r plus 1 factorial. Next is 1 by r plus 2 factorial plus so on up to infinity. Now we have to write it in the simplified form. So for that, what I do is 1 plus 1 by 1 factorial plus 1 by 2 factorial plus so on up to plus 1 by r factorial plus so on minus 1 plus 1 by 1 factorial plus 1 by 2 factorial plus so on up to 1 by r minus 1 factorial. I have written it like this because we know this sum is nothing but E. Though here it is N or R, the value will be equal to E only. E minus here first R terms of expansion of E. You have to subtract from E, you have to subtract first R terms of E. So this formula is very important. Summation n equal to 0 to infinity 1 by n plus r factorial equal to, from E you have to subtract first r terms of E, not r minus 1 terms, because r minus 1 terms here plus this 1 term. Therefore first r terms of E. See for example, summation n equal to 0 to infinity 1 by n plus 1 factorial equal to E minus first r value is 1 now here. So first one term of E, that is E minus, which is first one term of E, that is nothing but 1. So the value of this summation will be E minus 1. Now similarly, summation n equal to 1 to infinity 1 by n plus 1 factorial equal to. So in this case sum is starting from 1 to infinity. Therefore here E minus first r plus 1 terms of expansion of E. So that is equal to E minus first r plus 1 terms. Here n equal to r equal to 1. Therefore 1 plus 1, 2. So you will have first two terms of expansion of E, 1 plus 1. That is equal to E minus 2. So remember, you have to see the index. If it starts from 1 to infinity, 1 plus r factorial equal to E minus first r plus 1 terms of E. Then if it starts from n equal to 2 to infinity, 1 by n plus r factorial equal to E minus first r plus 2 terms of E. So seeing this index of n is very important. If it starts from 2 to infinity, r plus 2 terms. 1 to infinity, r plus 1 terms. 0 to infinity means first r terms of E, that you have to subtract from E. Now one more result, third one, summation n equal to 0 to infinity 1 by n minus r factorial into x to the power n, which is equal to now. So here there is negative, so n value less than r is meaningless. So you can have to start from n equal to r here. So you will have summation n equal to r to infinity 1 by n minus r factorial into x to the power n, which is same as x to the power r plus 1 by 1 factorial into x to the power r plus 1 plus 1 by 2 factorial into x to the power r plus 2 plus so on up to infinity. So if you take x to the power r common, then you will get 1 plus 1 by 1 factorial into x plus 1 by 2 factorial into x square plus so on. So this is the expansion of e to the power x. So this is equal to x to the power r into e to the power x. Therefore, whenever you have summation n equal to 0 to infinity 1 by n minus r factorial into x power n, then it is x to the power r into e to the power x. See for example, if you have summation n equal to 0 to infinity 1 by n minus 3 into x to the power n. So in that case, x to the power r value is 3. So x cube into e to the power x. Similarly, if you have summation n equal to 5 to infinity 1 by n minus 5 into x to the power n, that is also same as x to the power 5 into e to the power x. E power x is compulsory. Based on the value of r, you will have here the power of x. Here it is from 5 to infinity. Though if you have from 0 to infinity, it is the same answer. Therefore, these three results are must. The First one, summation n equal to 0 to infinity 1 by n minus r factorial, which is same as n equal to r to infinity 1 by n minus r factorial, and the value equal to e. The second result is summation n equal to 0 to infinity 1 by n plus r factorial equal to e minus first r terms of expansion of e. So if it is from 1 to infinity, e minus first r plus 1 terms of e. 2 to infinity, e minus first r plus 2 terms of e. Therefore, you have to see the value of the index n. And third result is summation n equal to 0 to infinity 1 by n minus r factorial into x to the power n is same as x to the power r into e to the power x, which is same as summation n equal to r to infinity x to the power 1 by n minus r factorial into x to the power n. Based on the value of r, you will have the power for x. E power x will always be there, then x to the power r. If a random series is given, then how to identify it as exponential series, that is feature of exponential series. The main feature is that each term of exponential series has a factorial in the denominator and power of x or some constant term in the numerator. This is the main point to identify the given series as an exponential series, because though e power x, that infinite representation of e power x, is called as exponential series, all the series need not be directly given in this form. We may need to bring it down to the standard form. Therefore, to identify that it is an exponential series, these 2 points play an important role. Let us see how to find the summation of an exponential series by keeping these 3 points in mind. See the first problem. Sum to infinity of this series. This is the given series. So to identify it as an exponential series, the conditions are it should have factorial in the denominator and a constant or power of x in the numerator. See, if you want sum of this, then name it as yes, 1 plus 2 square by 1 factorial plus 3 square by 2 factorial plus 4 square by 3 factorial plus so on. So, which is same as summation n equal to 0 to infinity n plus 1 whole square by n factorial. This is how the generalized term of this series is written. When you put n equal to 0, you will get 1 by 1 factorial, then n equal to 1, 1 plus 1. Second term is 2 square by 1 factorial, n equal to 2, 3 square by 2 factorial, and so on. It has factorial in the denominator, but the numerator should contain either power of x or constant. But here there is a second degree polynomial. So suppose if you have summation n equal to 0 to infinity f of n into x to the power n, if the given series has a new function f of n which is of degree n, any degree, then in that case we have to write that f of n as a naught plus a1 into n if the denominator has n factorial, that is f of n into x to the power n by n factorial. If the expression is in this form, then a naught plus a1n plus a2 n into n minus 1 if it is the second degree polynomial. Then if it is a third degree polynomial, one more term. Suppose if you have summation f of n by n plus 1 factorial in the denominator. So in that case, you have to write f of n as a naught plus a1 into n plus 1 plus a2 into n plus 1 into n plus like that, so on. Okay. Therefore, now here this is a n square means second degree f of n equal to n plus 1 whole square. This is a second degree polynomial. and denominator has n factorial. Correct? No. Therefore, you have to write this n plus 1 whole square as a naught constant plus a1 into n, because there is n factorial in the denominator. Writing it in terms of n plus a2 into n into n minus 1. So second degree polynomial. So up to n square if you get, that is enough. Don't write one more term. For second degree polynomial there should be three terms: constant, first degree, second degree. So now n square plus a1 plus 2n equal to a naught plus a1n plus a2n square minus a2n. You have to equate the coefficients now. This is constant n into a1 minus a2 plus a2 into n square. Here n square plus 2n plus 1. So equating coefficient of n square on both sides. 1 equal to, here n square coefficient is 8. I got the value of 8. Similarly, equating coefficient of n, 2 equal to, here a1 minus 8. So 8 2 is 1, a1 is equal to 3. Then equating constant, here constant 1 equal to, in this case constant is a. So I got all three coefficients. Therefore n plus 1 whole square is written as 1 plus a1 is 3 into n plus a2 is 1 into n minus 1. So I have written the given second degree polynomial in terms of n. That is because there is n factorial in the denominator. Because it should be in the standard form of exponential series. That's why all these simplification is done. Substitute here s equal to summation n equal to 0 to infinity 1 plus 3n plus n into n minus 1 divided by n factorial. So which is equal to summation n equal to 0 to infinity, split this 1 by n factorial plus 3n by n factorial plus n into n minus 1 by n factorial. Let us simplify this. So which is equal to summation n equal to 0 to infinity 1 by n factorial plus summation n equal to 0 to infinity. This can be written as n into n minus 1 factorial. So that 1n cancels. So 3 by n minus 1 factorial plus here also n into n minus 1 into n minus 2 factorial. So n into n minus 1 cancels. We are remain with summation n equal to 0 to infinity 1 by n minus 2 factorial. Now let us make use of our formula. See, we had here 1 by n minus r factorial or 1 by n minus r factorial from r to infinity or 0 to infinity, value equal to e. Let us make use of that. That's why we did all those simplification, bringing the second degree polynomial and writing it in terms of n, so that we can cancel out the term and we can bring it down to the exponential series form. So which is equal to this value, here r equal to 0, whatever may be the value of r, its value equal to e plus 3 is constant outside. So 3 into this is also e plus here value is 2, whatever may be the value of r, its value is e. So it is equal to 5 into e. So this is the summation of the given exponential series. See the next problem. Sum to infinity of this series. This is the given series. Name it as s is equal to 1 plus 1 square plus 2 square by 2 factorial plus 1 square plus 2 square plus 3 square by 3 factorial plus so on. There is factorial in the denominator. Therefore, using the sigma notation, 1 square plus 2 square, nth term will be n into n plus 1 into 2n plus 1 divided by 6. That is using the formula of squares of first n natural numbers, sum of squares. So into n factorial, and n starts from now 1 to infinity, because here it is first term 1 factorial, second term 2 factorial, third term 3 factorial. Therefore n is starting from 1 to infinity and this is the value. Now f of n equal to n into n plus 1 into 2n plus 1. This is a third degree polynomial. Third degree polynomial, and denominator contains n factorial. But you can still simplify this summation n equal to 1 to infinity n into n plus 1 into 2n plus 1 divided by 6 into n into n minus 1 factorial, so that n cancels. So in this case, you will get n equal to 1 to infinity n plus 1 into 2n plus 1 divided by 6 into n minus 1 factorial. Therefore, your f of n becomes now n plus 1 into 2n plus 1, which is a second degree polynomial, and denominator has n minus 1. Now write this f of n in terms of n minus 1. Therefore, n plus 1 into 2n plus 1, which is equal to a naught plus a1 into n minus 1 plus a2 into n minus 1 into 1 less n minus 2. So, therefore, n square 2n square, this is 2n square plus 3n plus 1 equal to a naught plus a1n minus a1 plus a2n square, this is n square minus 2n minus 1 minus 3n plus 2. So a2n square minus 3a2n plus 2a2. Equate coefficient of n square on both sides. 2 equal to here a2. So done. Then coefficient of n on both sides, 3 equal to a1 minus 3a2. So therefore we want the value of a1 equal to 3 plus 3 into 2, that is equal to 9. A1 is 9. Then we want constant, equating the constant on both sides. 1 equal to a naught minus a1 plus 2a2. Therefore, substitute a naught equal to 1 plus a1 is 9 minus 2 into a2 is 2. That is 10 minus 4, which is 6. A naught is 6. Therefore, the summation s is equal to, we will have here summation 1 to infinity n plus 1 into 2n plus 1 divided by 6 into n minus 1 factorial as summation 1 to infinity. This numerator now gets reduced to 6 plus a1 is 9 into n minus 1 plus a2 is 2 into n minus 1 into n minus 2 divided by 6 into n minus 1 factorial. This is equal to, split it, summation 1 to infinity 1 by n minus 1 factorial, 6 cancels, plus summation 1 to infinity 9 by 6 is nothing but 3 by 2 into 1 by n minus 2 factorial, because 1 n minus 1 cancels, plus 2 by 6 is 1 by 3 into summation 1 to infinity, split it as n minus 1 into n minus 2 into n minus 3 factorial. So n minus 3 factorial. As these term it cancels. So this is e plus 3 by 2 into e plus 1 by 3 into e. So which is equal to 6 is the LCM. 6e plus 9e plus 2e. So which is equal to 17e divided by, so 6e plus 9e plus 2e divided by 6, which is equal to 17e divided by 6. This is the answer. See, you can have two more formulae. We have value of e power, we have value of e power 1, e equal to 1 plus 1 by 1 factorial plus 1 by 2 factorial plus on up to 1 by n factorial plus so on. Similarly, you can get e power minus 1 as 1 minus 1 by 1 factorial plus 1 plus 1 by plus 1 by 2 factorial plus so on to plus minus 1 power n into 1 by n factorial plus so on. Now if you add these two, that is e plus e power minus 1, then you will get, which is equal to 1 plus 1 2, then this term cancels, then plus 2 into 1 by 2 factorial plus 2 into 1 by 4 factorial plus so on. So these terms will remain. So if you take 2 common, e plus e power minus 1 by 2 equal to 1 plus 1 by 2 factorial plus 1 by 4 factorial plus so on. So which is nothing but summation 1 by 2n factorial, n equal to 1 to infinity. So you can have one more formula. If you have 1 by 2n factorial n from 1 to infinity, then its value equal to e plus e power minus 1 by 2. Similarly, if you subtract the first and second equation, then you will get e minus e power minus 1 equal to 1 minus 1 cancels. Then next you will get 2 into 1 by 1 factorial plus 1 by 3 factorial plus 1 by 5 factorial plus so on. All odd terms will remain. So when you simplify this, it is same as e minus e power minus 1 by 2 is equal to 1 to infinity 1 by 2n minus 1 factorial. Therefore, the value of 1 by n factorial is e, but the value of summation 1 by 2n factorial is e plus minus e plus e power minus 1 by 2. The value of this factorial is e minus e power minus 1 by 2. These two formulae also you have to remember. Using this, let us solve one problem. Sum to infinity the series, this is the given series. There is a factorial term in the denominator. Therefore, s is equal to exponential series concept has to be applied. 7 by 3 factorial plus 9 by 5 factorial plus so on. We have to write it in the sigma notation. So what is the nth term of this series? First term is 5, second term all odd values here. So 2n plus 3. 2n plus 3 because when you put n equal to 1 here, 1 to infinity now, not 0 to infinity. Because when n equal to 1, 2 plus 3 you will get 5. That is the only possibility to be satisfied. Divided by how the denominator is. Denominator you should get 1. Therefore, 2n minus 1 factorial. So, 2 ones are 2 minus 1 gives you 1 factorial. This is how to get the nth term of the series. Therefore, keep this in mind. Now, summation is starting from 1 to infinity. There is factorial in the denominator, but numerator is a first degree polynomial. Therefore, I have to write it in terms of 2n plus 3 equal to a naught constant plus a1 into denominator is in terms of 2n minus 1. Therefore, you have to write this 2n plus 3 in terms of 2n minus 1 so that you can cancel out the terms. In the previous problem, there was n factorial in the denominator. So, you wrote numerator in terms of n factorial, that is in terms of n. But now it is in terms of 2n minus 1. So, simplify. Very easy. It is 2n plus 3 equal to a naught plus 2a1 into n minus a1. So, equating coefficient of n, so you will get 2 equal to 2a1, a1 equal to 1. Then equating constant terms, 3 equal to a naught minus a1, a naught equal to 3 plus 1, 4. Therefore, you got the series as n equal to 1 to infinity. Here a naught is 4 plus a1 is 1 into 2n minus 1 divided by 2n minus 1 factorial. I guess now you understood why you have written it in terms of 2n minus 1 so that you can split the summation. 1 to infinity, that is 4 by 2n minus 1 factorial plus summation n equal to 1 to infinity. So here 2n minus 1, this is 2n minus 1 into 2n minus 2 factorial. So 1 2n minus 1 cancels, 1 by 2n minus 2 factorial. So we have the formula summation 1 to infinity 1 by 2n factorial is e plus e power minus 1 by 2. Summation 1 to infinity 1 by 2n minus 1 factorial is e minus e power minus 1 by 2. So when you have odd values here, this is negative, even values positive. So 4 into this is odd. Therefore, e plus e odd means this is e minus e power minus 1 by 2 plus here even 2n minus 2 is even. So you will have e plus e power minus 1 by 2. So let us simplify this. 2 else here. 4e minus 4e power minus 1 plus e plus e power minus 1, which is equal to 5e minus 3e power minus 1 by 2. So this is the final answer. This problem is solved based on these two results, even and odd values. Only even value summation will come here. Here only odd value summation will come, not directly e here. This is e plus e power minus 1 by 2. This is e minus e power minus 1 by 2.